Okay, our first topic is solving equations. Um, so on number 1a, we want to notice that x appears on both sides of the equation. So typically our first step here is to simplify both sides. So I want to take, and when I say both sides, remember the equal sign is what's dividing it into two sides. So I want to take the left side and do any simplification I can. So those parentheses there mean I want to multiply by whatever's in front. If there's nothing there, that's like a 1. So multiplying, you would distribute the 1, and nothing would change. So essentially, you can just drop those parentheses to x plus 4. On the right side, the 2 needs to multiply by the binomial. So we're going to distribute that 2. 2 times 1 is 2. And then 2 times 4x is 8x. So we're on our way to simplifying both sides. On the left side, we can collect like terms. We have two linear terms here. So we have 1x plus 7x. We'll collect that into an 8x. And on the other side, we've got, if I rearrange it, 8x plus 2. So at this point, there's a couple routes you can go. When I start to solve, since x is on both sides, I want to subtract or remove it off of one side. So I'm actually using subtraction here because it's addition. So if I subtract 8x off both sides, I get 0 for the x for the linear term. And now I'm left with that statement, 4 equals 2. There is no variable left. When there's no variable left, that means that your choices are pretty much no solutions or infinitely many solutions. And the way you can tell is the resulting equation or statement that's left over. So we have 4 equals 2. That is not a true statement. That is a false statement. So 4 does not equal 2. I kind of say that that's false or not true. So what that means is that we have no solutions. That would mean that if it were a true statement, you would have infinitely many solutions. So let's say, for instance, we got 2 equals 2 or 0 equals 0 or something like that. Then that would mean infinitely many solutions because this is a true statement. Another thing that you can do with this type of problem is you don't have to subtract the 8x off both sides. You could recognize that when the linear terms or the parts with the variables are exactly the same on both sides, they will cancel. And so you can look at the remaining part of each side, the remaining terms, and decide if they're the same, it's infinitely many solutions, and if they're different, it's no solutions. So a lot of people just stop right here and say, look, the x's match, so that means they're going to cancel when I subtract off both sides. And then the 4 and the 2 remaining would be, since they're different, we're going to have no solutions. Okay, let's take a look at part B here. So on this one, there's no simplification due on either side of the equation. Remember, sides are determined by the equal sign. We have a left side and a right side. There is no simplification, so we just start solving. Now, x does not appear on both sides. It appears on the left side, so that's good. We can just start getting rid of or removing all the other stuff around the x so that we have just x left over. So since I'm adding 1 to x, I've got 5/2 x plus 1. I want to do the inverse of addition first. I want to subtract 1 off both sides so that I can, what we say is cancel. So we get 5/2 x plus 0 equals 30. Okay, now on this step, when we have a fraction times x, there's a couple ways to look at this. I'm going to show you the first way to think about it. Since it's multiplication, we do the inverse operation on both sides of multiplication, which is division. The problem here, or not problem, but the process here is when we divide by a fraction, we really need to, instead of dividing by 5/2, we need to multiply by its reciprocal. And that's going to be true on both sides. All right, so on the left side, 2/5 times 5/2. When you multiply reciprocals, you always get 1. So I would get 1 times x, which is just x. So now we've solved for x. X is by itself. On the right side, there's a couple ways I could do this as well. I could say it's 30 times 2 and then divide by 5. I could do 30 divided by 5 first, get 6, and then times 2. Or I can call it 30 over 1 and multiply my fractions. I'm going to choose to do 30 divided by 5 is 6, and 6 times 2 is 12. So there's your solution. There is only one solution. X equals 12. Okay, let's look at our last two solvings of equations. So this one needs some simplification on the left side of the equal sign. So I've got 4x. I distribute my negative sign, plus 1, and then 11 plus x. So I'm now going to collect my like terms over here on the left side and get 4x minus 3x is 1x. So once again, I notice if I rearrange the right side, the x's match. The other parts do not match, so that's going to be a no solutions again. Remember, if they do match, it's infinitely many solutions. All right, let's look at the next one. I distribute my negative 2x. Distribute my negative 2, so I get negative 2x, and then I get negative 2. On this one, again, I notice my x terms, my linear terms match, but also the other parts also match. So that's an infinitely many solutions because it's a true statement, that equation.